Hi, MC Bling Daddy here with the 9th video in the CVC Coding Engine series. Since each video in this series depends on previous segments for details on usage, you may want to review previous presentations before you continue with this one. Last time we looked at switches in order to increase the power and flexibility of for loops. This time we'll use the latest elements that have been added to our engine, the left side of the switch, so that we can use the full power of the switch with lessened space requirements and more flexible code generation capabilities. But we'll also explore the emergent properties of using nested coding elements, in particular with for loops. First, we'll add in the additional switches we couldn't last time, utilizing odd for loop 2 indexes to use odd numbered subs. Review video 7 and 8 for setup of switches and for their call to subs. Next, we'll give ourselves some space to insert a new for loop, nested between beginning and ending of loop 2. See videos 5 and 6 for details on setting up for loops. Naturally, we'll call it loop 3, and we'll put it in the spaces we just made, the beginning coming just after the beginning of loop 2, and the ending coming just before loop 2's end. Now, as you may remember, loop 1 starts at the beginning of the code and finishes at the end. It raises levels of the towers we've been building from 1 to the desired height, and we've typically been using 5 lately. Loop 2 is nested inside of that and has been used to iterate through a series of lines of blocks that generate each level. It iterates from 0 to 7 because we have subroutines numbered from 0 through 7 that create lines of blocks in various directions around the y-axis. See video 7 for details on these subs. In video 8, we inserted duplicate code to generate chains 2 blocks long. You can see the redstone dust we've replaced the duplicate coding blocks with. Now, the subs, again, generate only a single block in their assigned direction. We've also added a few new subs, S10 through 17, that mimic S0 through 7. Remember that S0 through S7 generate horizontal chains of blocks. S10 through 17 move in the same directions as S0 through S7, but they simultaneously move upward a block. So when used multiple times, they generate a slope rather than a flat surface. Let's take a quick look at the new loop, loop 3, and review the switch. Remember that loop 2 still iterates through the various subs, 0 through 7. However, loop 3 is totally inside loop 2, and so for whatever sub loop 2 has selected, loop 3 can repeat several times, 2, as you see in our code, doing its thing. And its thing? Determined by the switch. You see, the test it uses is based on loop 2, so whatever the index of loop 3, the switch will call a sub based on the index of loop 2. In this case, sub S0. So for loop 2, index 0, the switch will repeatedly call S0, however many times loop 3 calls on the switch. There will therefore be a line of blocks in the direction of S0 based on how many times loop 3 repeats for each loop 2 iteration. Then loop 3 will end. Then go back to loop 2, where the next loop 2 index will be used, and so on to sub S7. So we'll get, roughly, an octagon, as specified by 0 through 7 in loop 2, the length of each side being specified by loop 3, currently set to start at 1 and finish at 2, so 2 additional blocks. But note that each segment starts at a block and extends out. Since 2 blocks will be added, each segment will appear to be 3 blocks long. We'll take a quick look at switch case 1 to see that it's structured the same as all the even cases. See video 8 for details on how to set up switches. The left side is not really any different than the right side that we used last time. To use space most effectively, however, cases should alternate sides. Don't put two of the same type side by side. In order to get loop 2 to use switch case 1, we need to change the increment value, inc, from 2 to 1 so that we'll use all the values from 0 through 7 rather than just the even ones. So, let's get a view and see how the code works. Some things you can see while the program is running. First, when the switch is activated, one of the torches next to the command execution blocks will light up sequentially, hence alternating sides, since the switch cases 0, 1, 2, etc. are controlled by loop 2. Second, each will light during 2 consecutive activations, however, prompted by loop 3, before the next is lit on the other side of the switch. Third, the current index, cur, for each loop shows on the right side of the screen. Although their positions change, putting the biggest at the top, you'll see loop 3 change most rapidly, then loop 2, and loop 1 most slowly. Loop 1 and loop 3 start at 1, loop 2 at 0, since that is their initial ini value, and go through to their final fin value plus 1. Since they have to exceed the fin value for them to stop and restart their loop. Fourth, you can't really see the comparators except on the 7th, on the right side of the switch nearest to us as we are viewing it. But when the 7th case is selected, you can see the comparator is lit and remains lit until the next case is selected. Again, that's why a gate is needed, and each set of case blocks is so complicated. And by the way, the next case after 7 would be case 0 at the start of the next iteration of loop 2. Let's finish this run by speeding up the rest. As it turns out, the code we've generated so far is capable of doing a number of other things simply by changing a few variables and using a couple of the new subs. First, we'll set the world cursor, WC, in a position to allow it to rise in a different direction. Next, we'll set the fin value of floop, which tells us how high we'll go, so it doesn't exceed the width needed for our new construction. Third, we'll set each pass through floop to rise in the negative z direction. And finally, we'll do something you should never do in real life. We'll change the floop 3 parameters within that loop. We're doing it because the length of the lines of blocks needs to change depending on whether the line is along an axis, i.e. floop 2 cur is even, or whether the line is diagonal, i.e. floop 2 is odd. Normally, that would require a switch after an index change in floop 2 to set the floop 3 fin value, but that would take inserting a switch in the code, and I just want to do a quick demonstration here. So instead of inserting that code after the start of floop 2, we'll use the switch we already have inside floop 3 that executes code based on the value of floop 2 cur. For even values, we'll change the final value for floop 3 fin to keep the original floop 3 fin parameter, which happens to be the same as the new floop fin value. For odd values, we'll change it to equal floop remaining, rem. What this does is basically to count down from fin rather than up from 1. So even lines will be extended by fin blocks. Odd line additions will start at fin long and work their way to 1. We'll see one of the command blocks changed, then the others behind the scenes. Let's get a view and see what all that fuss was about. The WC moves up now before a circle of blocks is laid down, and each time the count of horizontal and vertical blocks added in remains the same at 2, controlled by F-loop 3 fin, which in turn is now the same as F-loop fin. F-loop 3 fin is 2, as it was while the walls were generated. The number of diagonal blocks, on the other hand, drops from 2 to 1, because we are using F-loop rem as the count, and it counts down from F-loop fin, which is 2. It would go to 0 if F-loop didn't end, because rem is 0. This also points up, again, that it's possible to use parameters from outer loops within the inner loops, and to remind that rem can be used to count down, as opposed to cur, which counts up. There's still another thing we can do to finish the top by further modifying the code we have. The rest of the roof will have only horizontal and vertical segments, no diagonals, and although they start off with extensions of 2 blocks each, they get smaller at each level by 2. So we can use F-loop rem like we did for the diagonal segments just now. And since we've already seen how that's done for diagonals, we'll do it behind the scenes for the horizontals and verticals, the even indexes of F-loop 2 in the switch. But other things we have to do include 1. Place an offset brick block left of WC, then teleport WC to it. 2. Since the length of each segment decreases by 2 each level, we have to set F-loop inc equals 2. Unfortunately, that'll only give us one iteration, starting at 1, then going to 3, which is outside the loop. 3. Since the repeat direction we have to move WC is diagonally upward, we have to change the F-loop transfer, or call, to go to S11. And 4. Because we're only doing even subcalls, we have to change F-loop 2 inc to 2. But we have already changed those switches affected by this in F-loop 3, as was just mentioned, for how many blocks get added to a segment for even F-loop 2 indexes. And we'll start execution. It's possible to write proper code that will take these demo changes into account. That's for another video, though. But for this video, that's it. And thanks for watching.